This is the second of 2 narrated PowerPoints for the new formulas for the last third of the course. Here we're going to be talking about the age of the universe. And this is only an approximate value, but hey, an approximate value is better than nothing, right? So we're going to use the fourth or the last of the equations in this part of the course. This is the age of the universe, t for time, equals 1 over h, our friend the Hubble constant. And this 10 to the 12th, that's a conversion factor. Remember that h has wonky units. Remember that h had units of kilometers per second per megaparsec. So if we wanted to do this formula just starting with 1 over h without this part over here, we would have to convert kilometers into megaparsecs and then seconds into years, and that would just be a pain in the neck, and we don't want to do that every time we do a problem. So some nice person has already done all of those unit conversions, and the unit conversion is a trillion years, give or take a few, so a trillion-ish. So this 10 to the 12th years is not magic. It's doing all the unit conversions for converting all of this stuff into years. Isn't that nice? Here's a typical problem. If h is 82 kilometers per second per megaparsec, what is the approximate age of the universe? Remember that all of this stuff is going to get converted already by this trillion at the end. So all we need to do is say that the age of the universe is approximately 1 over 82, and then at the end, multiply that by 10 to the 12th. So on your calculator, take 1 divided by 82, and that will be 0.012, and then multiply that by 10 to the 12th. And you get 1.2 times 10 to the 10th years. You get a big number. Well, don't we expect a big number? Now, you were perfectly okay leaving it like that. But if you want to compare it to the value that we accept for the age of the universe, this can also be written as 12 times 10 to the 9th years, or 12 billion years. And considering that the accepted age of the universe is around 13.7 billion years, we can see that we're in the ballpark. Here's another example. If h is 64 kilometers per second per megaparsec, what is the approximate age of the universe? We're going to do the exact same thing. We're going to say that the approximate age of the universe is going to be 1 over 64 times 10 to the 12th years. Remember that the 10 to the 12th takes care of all the nasty unit conversions for us, so we don't have to worry about that at all. All we need to do is take 1 divided by 64, and we get 0.0156 times 10 to the 12th years. So we multiply this times 10 to the 12th. We end up with 1.56 times 10 to the 10th years. Again, a big number. We expect a big number. You are perfectly okay with leaving that number just as it is, or we can also write it as 15.6 times 10 to the 9th years, or 15.6 billion years, which is just a tad older than the accepted value of 13.7 billion years.